Hello, in this video, I am going to discuss about the effect of feedback on input impedance of an amplifier. So in the right hand side, we have got an amplifier circuit. We have a schematic of amplifier with feedback. So here, let Vs be the applied input voltage. Vi is the Vs is the applied input voltage. Vi is the input voltage applied to the basic amplifier. The basic amplifier means the only amplifier I'm talking about without the feedback. And Vf is the feedback voltage applied to the input. Okay, so let's see. Now now here uh, let Zi be the input impedance without feedback. Input impedance without feedback. Okay, Zif be the Zif be the input impedance. Oh, sorry, Zi is the input impedance without feedback. Without feedback. And ZIF is the input impedance with feedback. Okay, with feedback. Z0 is the output impedance. Output impedance without feedback. Without feedback. And we have got ZOF as output impedance with feedback. Okay, with feedback. So now we know that Vi, that is the input voltage applied to the basic amplifier, is equal to Vs minus Vf as from the diagram. Okay, and next we can write Zif is equal to Vs divided by Vi. Oh, sorry, I. It is Vs divided by I, where II is the input current. Okay, here II is the input current. Okay, so next, so from this, what you can write? From this we can write I, the input current, is equal to Vi divided by Zi. Okay, and Vi is equal to Vs minus Vf. Okay, Vi is equal to Vs minus Vf, as we have already mentioned here. Okay, divided by Zi. Okay, now we know that Vf you can write, but Vf is equal to beta times of V0. So what you can write now, this input current II becomes Vs minus beta times of V0 divided by Zi. Okay, now from here what you can write, Zi is equal to Vs minus beta V0. Okay, so this is, for example, equation number 1. Okay, now we know that A, that is open loop gain. A is the open loop gain, we all know. That is the gain of the amplifier without feedback is equal to V naught by Vi. Okay, this gives V naught is equal to A Vi. Hmm. So equation 1 becomes what now? So therefore equation 1 becomes II into Zi is equal to Vs minus beta into AVI. Okay, because V naught is equal to AVI. So this gives II times of Zi is equal to Vs minus A beta Vi, and this will give II times of, oh, this you can write like this, Vs, here Vs becomes II Zi plus A beta Vi. Okay, now what is Vi? Vi is equal to II into Zi. Okay, since Vi is equal to II times of Zi, so this gives Vs is equal to II times of Zi plus A beta II times of Zi. Okay, now what you can write? You can write here now Vs II Zi is common, 1 plus A beta. So for example, this is equation number 2. Okay, so now we already know that from here there is a relation we have already mentioned. This ZIF is equal to Vs by II. Okay, so we'll use this relation since ZIF is equal to Vs by II. This gives ZIF is equal to, what is Vs? Vs is equation number 2, that is II times of Zi 1 plus A beta divided by II. So this gives you, I can write here ZIF is equal to Zi 1 plus A beta. Okay, so we can see now this is the expression that shows the effect of feedback on input impedance. ZIF is equal to Zi in bracket 1 plus A beta. Okay, now for negative feedback, we know that for negative feedback, this 1 plus A beta is greater than 1. Okay, so what will happen? This gives ZIF so here ZIF becomes greater than Zi. That means for negative feedback, the input impedance increases with feedback network. That is, we can consider it as case number 1. Case number 1, that is for negative feedback. For negative feedback, input impedance increases. Input impedance increases. Okay, so ZIF is the input impedance with feedback. Okay, and ZIF is greater than ZI. ZI is the input impedance without feedback. So with negative feedback, the input impedance increases. Okay, now for positive feedback, what will happen? Case number 2, for positive feedback, this we know that 1 plus A beta is less than 1. This gives ZIF is less than ZI. Okay, that is with positive feedback, input impedance decreases. Okay, input impedance decreases with positive feedback. So this is about effect of feedback on input impedance. Thank you very much.